Let's consider the Lewis structures of the atoms of the various elements. This is the first step towards an important skill, drawing molecular structures, or Lewis structures of molecules. We're going to focus on valence electrons. Valence electrons are the electrons in the highest shell, the highest energy level or orbitals of any given atom. In metals, these are the electrons that would be lost in an oxidation. In nonmetals, these are the electrons that would be added to when we reduce them. Remember, reduction is the adding of electrons. In metalloids and nonmetals, these are the ones that will be shared, that will participate in covalent bonds. How do we represent the atom's electrons? Well, we're going to show them possibly as numbers in an electron configuration. So lithium, 1s2, 2s1, and the highest energy, or last electron, is the valence electron. It has one valence electron. We could also show atoms in boxes, the electrons of the atoms in boxes, to emphasize the pairing of the electrons. Lithium, so, has the 1s, there's a box for the 1s orbital, and it has 2 electrons, and they're antiparallel. It also has the 2s electron, and that's all by itself. But Lewis diagrams are a very convenient way to work, because they show only the valence electrons. And the valence electrons are the only ones who are going to be involved in any chemistry. So elements in the same column of the periodic table will always show the same Lewis diagram. Let's look at an example. Oxygen. Oxygen has 8 electrons, but 2 of them are in the inner core, the helium core, if you want to call it that. And so it has only 6 valence electrons, and here they are. 1, 2, 3, 4, 5, 6 valence electrons. But if you look at sulfur, right below it, since it's in the same column of the periodic table, it too has 6 valence electrons. Selenium and tellurium would have the same Lewis structure. So oxygen and sulfur are both in 16, and they both have 6 valence electrons. How do we do this? Well, again, only valence electrons are shown, so you first got to count the valence electrons. And you get that really from the number out of 8, because 8 is really pretty much the highest you're going to go to. You're going to look at the column of the periodic table and count from the left. Then you're going to distribute that number of electrons clockwise around the symbol. So, given that element X has 6 valence electrons, like oxygen and sulfur, here's how we do it. We write the symbol, and then we write clockwise 1, 2, 3, 4. Now you could have started at any one of those. Then you have 2 more, 5 and 6 are paired up. And notice that this follows Hund's rule. We half-filled orbitals before we completely filled any. So, you draw the Lewis structures of hydrogen, lithium, beryllium, boron, carbon, showing 4 separate electrons, fluorine, and manganese. That one might give you a little trouble. So turn the video off, and then we'll talk about the results when you come back. Hydrogen has 1 electron, so we just write H and put a single dot next to it. Now lithium has 3 electrons, but 2 of them are in the inner or helium core, so we would draw Li and 1 electron. Beryllium has 4 electrons, 2 in the core, so we'd write Be and 2 dots, 1 on each side. Boron similarly would have 3 dots around it, and carbon would have 4. With fluorine, we would draw an F, and then it's got 7 valence electrons. So we draw 1, 2, 3, 4, 5, 6, 7. There would be only a single unpaired electron, giving it an odd number of valence electrons. Manganese, if you look carefully at it, looks like it would have 7, but we don't draw it that way. Manganese has those 2 4s electrons sitting out on top, and it's got 5 3d electrons, which by the time you add that 5th valence or 5th nonvalence electron into manganese, that d orbital set has sunk below the 4s. So those 2 4s electrons are going to be coming off. Manganese would be shown then with 2 electrons to give away. Here is a short form periodic table with Lewis dot diagrams of selected elements. Just remember, hydrogen is not an alkali, but it does have 1 valence electron to share. The rest of the group 1s would be giving away their electrons here. And notice also that in each column the number of valence electrons is going to be the same. Now what's next? Well, in the next unit you're going to use Lewis diagrams to draw 2-dimensional models of chemical compounds. You're going to have to start off with a Lewis structure of the individual elements.